So we've got a roller coaster. It keeps going. Now, we know that energy is conserved. So if we're sitting up here at rest, let's say this is point A, way up here, HA above the ground or above the lowest point. We can put our reference point, meaning potential energy is 0, anywhere we want to, because it's our physics problem. So at point A, if we're at rest, all we're going to have in terms of energy in the system is potential energy. Now, if I want to know, for example, how fast I'm going down here at point B, well, I know that energy is conserved, so the energy at A better equal the energy at B. At B, we're all about kinetic energy. We have no potential energy left at that point because I said so. If this is, say, point C, and I want to know the speed with which my roller coaster's going, well, I'm not as high as I was at point A, but I still have some potential energy. I also will have some kinetic energy. How much? Well, it depends on the difference between these heights, but I know that the energy at C better equal the energy at B, better equal the energy at A. The potential energy at A is all about how high up I am. At B, I'm all about kinetic energy, so I can figure out how fast I'm going. At C, I have some potential and some kinetic. So you do the math, but it looks to me like your mass, or the mass of this whole cart, and you in it screaming, "Ah!" is irrelevant to the problem. So let's just say I don't care anything about B. Let's say I want to know the speed at C. I don't really have to know what's going on at B at all. That's just some intermediate step. The masses I just said didn't matter. I can move this term over to that side of the equation. I see that I have a G, gravity, common to both terms that I've moved over. I can multiply both sides by 2, and I will get the speed at C squared. So why not just take the square root of both sides of the equation and be done with the problem? Now, as long as I've got meters and meters per second squared, and I'm working with SI units, then my speed's going to be in meters per second, and voila, I'm done with the problem.